Hi Gladiators! Today we're going to talk about how to construct a Bohr model. So up to this point we've been using our periodic table to identify elements based on their groups and their periods, and then we've been continuing that by talking about the number of subatomic particles of each element based on the mnemonic 8-man. So the next step is to actually construct a Bohr's model, and it's sometimes referred to as the circle model. So we always start by completing 8-man. So looking at aluminum, we're going to complete 8-man first. So if we look at 8 first, we're going to look straight here at that atomic number. So the atomic number is 13. The atomic number is the same as protons, so we have 13 protons. Protons and electrons have to be equal, so we also have 13 electrons. Now let's look at the man portion. So for the man, we have the mass minus the atomic number equals the neutrons. So for this, we're going to have to look down here to the mass. Now remember, for the mass, we have to round that first. So when we're rounding, 26.9 becomes 27. Bring over the atomic number. Subtract 27 minus 13 is 14. So now we have all the information that we need to be able to construct a Bohr model. Now the rules for the Bohr models. We start with the nucleus. So you're going to start inside the nucleus. Now for my nucleus, I'm going to actually draw a square. It's easier for me to keep straight that this is the nucleus. So it would be really difficult to add 13 protons and 14 neutrons inside that square and still be a nice, neat model. So we're just going to put P and N. So our protons equal 13 and our neutrons equal 14. So now my nucleus is complete. So now the next level is to add the electrons. So when we're talking about the electrons, we're adding energy levels. Remember back when we talked about the town of Matterville and Perky Patty and Nerdy Nelda and Enraged Elliot, there were rules to the number of enraged Elliots that could fit on any street. Well, it's the same thing with the electrons. We call it the 288 rule. So the first energy level can only hold 2 electrons. The second energy level can hold 8. And the third energy level technically can hold up to 18, but we consider it full at 8. So that's the 288. So we start closest to the nucleus and draw our first energy level. So we said our first energy level can hold up to 2. So if we go add our electrons, and I'm going to use a dot, we have 1, 2. Now that energy level is full. We cannot put any more electrons, so we have to go to the next energy level. So we add another circle. Now, according to our rule, we can fit up to 8. We've already put 2 on here, and we're trying to get to 13. So 13 minus 2 is 11. So I still need 11, so I can only put 8. Now you notice I'm going to do them in pairs. The reason I do that is really just to make a neater model. As long as you have the correct number on the correct energy level, it would not be counted wrong. Alright, so if we look now, we have 2 here, and we have 8 here. So we have a total of 10 on our model. I still need 3 more, but my energy level is full, so I have to go to the next energy level. So we're going to have to draw another circle. Now, I'm going to add my remaining 3. So when I look at that model, I have 13 protons, 14 neutrons, and if I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 electrons, remembering our 288 rule. So the electrons, it's a 288 rule. 2 in the first energy level, 8 in the second, and 8 in the third. Now, I want to point out that there's some really important electrons on here. So when I look at my model, I want to highlight those on the outside. 1, 2, 3. The electrons in my last energy level have a special name. They're called valence electrons. So if we look, we have valence electrons. So in aluminum, we have 3. Now, as we look at those valence electrons, they become really important as we go forward and start talking about how those electrons bond together. They bond at the valence electrons. Right? So when we look at our model, we look from the nucleus and build outward. Start with your protons and neutrons, and then build energy levels as you need them. Do not go to the next level until that level is full, following the 288 model. Okay? All right, Gladiators, we're going to practice this today, so if you have any questions, always get in touch with us.